Hello and welcome to another statistics video created by me. In this video podcast, I will show you how to calculate the regression formula using Excel. As we know, the regression formula or equation is y equals a plus bx plus some sort of error, where y is the dependent variable, x is the independent variable or the predictor, a is the intercept or the constant, b is the slope or the regression coefficient, and e is the error. Let me go back to Excel here, where I have a data set. I have a study of hours that students actually studied and the score that they got in an exam. So I have two variables. The predictor or the independent variable is the hours that they studied, and the output or the dependent variable is the score that they got in the exam. First, I want to see if the hours that they studied are a good predictor of how well a student will do in the exam. Right? So in the column hours or X, I have the independent variable. All of these are the hours that the student studied, and I see here that I have 26 observations. Each of the observations is a student in this case. And in the column Y, I have the scores that each of these students got in the exam. Okay, so the first thing we need to do here is to calculate the slope or the B. That's why I have this formula right over here. It looks a gigantic and somewhat really difficult formula, but actually it is not. So the B is equal to the sum of all x minus x bar times y minus y bar, where x bar is the mean of all the x's and y bar is the mean of all y's, or the scores, divided by the sum of square deviations of the independent variable x. In other words, right, this is nothing else but the ratio of the sum of squares of x and y by sum of squares of x, which is this representation here in the formula. As we know, the computational formula for sum of squares of x and y is right here, and sum of squares of x is right here. And actually, when you use Excel, these two formulas, the sum of squares, are easier than the computation of this formula here on top. But for the sake of this particular podcast, I will show you how to do this big formula here, because the sum of squares of y and sum of squares of x in this fashion, as it's shown in the other two formulas, is shown to you by me in another podcast. You can check that out later if you want to. So what do I need here? I need, first of all, to find the mean of x, to find the mean of y. Right, so I can find the mean of x right down here and the mean of y down here. Then I can find the difference between each of the scores by the mean of x and by the mean of y. When I find that result, I will multiply them together, so x minus x bar times y minus y bar. And another step would be to square the difference of the predictor, the difference of x minus x bar. Then while I have all of these things, I will get the sum, and I will find the B, or the slope of the equation of this regression. Okay, the first thing I need to do here, and this is a trick, is to, after I put all of these scores here, or numbers, is to format this as a table. The table has many advantages, one of which is that once you do one equation or one formula, the table will fill out every row for you. Okay, to do this, you have to just click inside any one of these rows, right? And in the Home tab, you move your mouse down to the Styles group and then click on Format as Table. Find any table format that you want. I want this light green color, because green goes with Excel, I guess. And I will click on OK. Make sure that my table has headers is checked, because actually my table has headers. And I will click on OK. OK. So now I have the table right here. The first thing I need to do here after I created the table is to find the mean of the independent variable and the mean of the dependent variable. To do that easily, while you are in the table and the design tab is in focus, make sure that you click this total row so that a row will be added right here at the bottom of the table. You see, when you click outside the table, you don't have that design tab, so click inside the table to have the design tab appear for you automatically. So click on the row tab, and immediately you'll see that there is a total row here. If you click on the cell immediately below the column of X, you'll see this drop down arrow, and if you click there, you would have a different list of functions, right? I need now the average here. You may be used to seeing the sum, but I need the average because that's the X bar. Now I go into the cell for Y, and I get the Y bar, which is the average, and that's it. With one click, you get the mean. Rather than adding all the scores up and dividing by the number 26, which is the number of samples, you can do that right here with the average function. Now, all I need to do is X minus X bar, so find the difference between each score from the mean of that variable. That will be equal sign, you start the formula with equal sign, the score, right, minus the mean. Then hit enter, and this is it. That's why a table in Excel is very, very helpful. Let's do the differences of each score from the mean for variable score. Equal sign, the score for first student, minus the mean of that variable, hit enter, and now I found the differences of Y minus Y bar. Next step would be to multiply this sum with that sum, or this result with that result, because that's what we need here in the formula, right? So that would be equal sign, this number, times, asterisk, right? This other number, hit enter, and I have that multiplication. Next step would be to square the differences of the independent variable X minus X bar. So that would be equal sign, this number, which is X minus X bar, squared, or this little hat, 2. Okay, so I have everything I need right now. Do I? No, we need 2 more steps. One is to find the sum of the multiplication of X minus X bar times Y minus Y bar. And X minus X bar times Y minus Y bar is right over here, so I need the sum of that. So all I need to do is go into the list and get the sum. That's the sum, right? What other do I need? I need the sum of the squared deviations of X minus X bar, so the sum of all of these numbers right here. So I go here, I have the count, but I don't want the count, I want the sum, and that's that. So what is B actually? What is slope? The slope is just the variation, okay? It's the ratio of this sum by that sum, right? The sum of the variation or the deviation of both variables divided by the sum of the variation of the sum squares. So the B now, right? I'll do B equals, right? And I will format that so that it aligns to the right. Will be equal sum of X minus X bar times Y minus Y bar divided by, so we put slash, divided by the sum of squares of X. Hit enter, and this is our B. Okay, this is great. What about A? What about the intercept now? We found the slope, and we need the intercept. And by the way, we will interpret the slope and the intercept as we go along. The A is this formula right here, which is the mean of the output variable minus B, slope, times the mean of the independent variable. So A, right, will be equal to, and I will format that so that it aligns to the right, will be equal to, right, the mean, which is Y bar, the mean of the scores, minus the slope, B, that we found using that all that calculation, times, times X bar. X bar is the mean of the hours studied. hit enter, and that would be the slope. So here's a quick interpretation of A and B. A is the intercept, or the constant. That is the point where the regression line intersects the y variable, or y-axis in the graph, regression graph, right? So that is the point of the dependent variable when the independent variable is 0. So in concrete terms here, that is the number of the score, okay, when the number of hours studied is 0. So if a student studied nothing, 0 hours, that student will, according to this model, will get 54.65 points anyway. Okay? What about the B? What is the slope? The slope is the rise over run, is the increase in the dependent variable for 1 unit increase in the independent variable. In concrete terms, that would be that for each hour increase in study, the score will be increased by 3.78 points in the overall score. So if a student studies 1 extra hour, that student will get an increase in the score, overall score of the exam by 3.78 points. Okay, according to this model, right? Let me show you one other thing that is very, very important in Excel. Rather than doing all these calculations, but I think you should be able to do this anyway, right? But in case you are pressed for time or you are too lazy to do this, then there is another easier way, right? And that easier way would be using the Data Analysis Toolpack. The Data Analysis Toolpack is found in the Data tab, all the way to the right side here. In the Analysis group, you have Data Analysis. So once you click Data Analysis, you are presented with a Data Analysis dialog box. Scroll down, find the regression, and then click OK. In the regression dialog box, you need now to select the input y range, or the dependent variable. The dependent variable is the score. I will include the header. I will tell you in a second. So the whole score, do not include the mean, right? In the input x range is the independent variable, is the x right here. I will include the header as well, right? So now I selected the y and x range. I want the labels, and that's why I included the header, because the labels will be there, you know, to tell us what these independent and dependent variables are. The confidence level is 95%. That corresponds to 0.05% significance level or reference probability. I want the output range to be in this particular area, not in another sheet, but I could actually do in another sheet. And actually, let me do that, because in my how to use Excel videos, I used the same sheet to show it. Right now, I will use a new sheet in Excel. In the residuals, I want the residuals, which is the error. I want the standardized residual. I don't want the residual plots, but I want the line fit plots, and I want the normal probability plots. Let's see what all of these things will come in the output of regression. So I click OK, and immediately Excel switches to the new sheet, gives us the summary output. Here's what we have here. We have the multiple R. The multiple R is actually the correlation coefficient. So we have an R of 0.56. Actually, that shows that there is a strong relationship between these two variables, right? R squared is the R squared, and this is actually a great way to find out how much of the variation in the dependent variable, the score that we got in the exam, is explained by the hours of study. There may be other factors, right, that explain the score. For example, how smart the student is. But also the hours explain this much of the variation in the score of the exam. And that, in terms of percentage, is 31.45%. So 31.5% of the variation in the scores in the exam is explained by the number of hours studied. That's a good portion, right? Almost 1/3 of the score is actually dependent on the number of hours that you studied. The adjusted R-square, this is the real R-square. This is the real percentage, so it's 28.59. So it's about 29% that the real variability or variance in the score in the exam is explained by the number of hours. The standard error is here, which is standard deviation of the normal probability. As you know, the number of observations was 26 students. This is the ANOVA table that we've talked about before, right? And this is the sum of squares for the regression, and this is the residual. This is the mean square, and the mean square for regression or model divided by the mean square for residual or error will give us a very, very significant F, which in terms of the p-value is this low, so that's smaller than 0.05, but we'll go back to that in a second. This is the most important table here. This is the most important table. That's the regression table. This number here is actually a scientific notation, so I will change that to a number, increase the decimals, and we can see here the real probability value. But the first thing that we need to see is the second row. The second row has to do with the slope, with the dependent variable, with the variable of interest. And that means that the slope that we actually got in the other sheet right here, right, 3.78, and we get that in this output for regression 2, 3.78. This is actually the rise over the run, meaning this is the change in the exam score for each 1 unit of independent variable for each hour. So if the student studied 1 extra hour, right, that student will increase the score in the exam by 3.78 points. Okay, so that's the idea. The standard error of that is 1.14. The t-statistic that was conducted by Excel in this case is 3.31, which is very significant. And actually, if you see this number right here, 0.0028, is the same as the F p-value. And that is telling us that this relationship between hours of study and the exam score is significant, meaning that the hours of study are very significant in explaining or affecting the exam score that the student will get, right? Because this p-value is smaller than 0.05, therefore we reject the null hypothesis that there is no correlation or supported relationship between these two variables, and we accept the alternative hypothesis that there is such a supported relationship. There is an effect that hours of study have on the overall exam score. Okay? Now, what about this other one? We talked about the coefficient. This is the intercept, or the constant. This is the point where the regression line cuts the y-axis, meaning if the student studied 0 hours, that student will get at least 54.65 points in the exam anyway, right? The t-statistics did this much, and the p-value is really, really, really small. This actually means that there is some variation in the exam scores, even though there is no variation in the independent variable hours of study. Okay, so basically that's the interpretation of the regression output. Then we have the residual output and probability output. We're not going to talk about them in this particular podcast. But the line of the fit line, I just want to show you here. We can see that this line goes from the lower left to the upper right, and it has an upward trend. That means that there is an increase in the score, overall score of a student in the exam, if the number of hours increases. So for example, right here, if the student actually studied 8 hours. If we go up here, the point where 8 hours touches the regression line, and we draw a line here in the, actually I will do that right now. So if I take a line that goes from 8 hours, touches here, and then I put another line from the point where 8 hours touches the regression line, we would get, according to this model, that the student would have gotten at least 80 points. The last thing I need to tell you here is to construct the regression formula. I'm going to go here and I will construct the regression formula right over here. So the regression formula would be y equals a plus bx. What does that mean? We have a, we have b, and then we can claim what x may be. And with this regression formula, we can answer a question like this. What is the predicted value in the score of the exam for a particular student who studies 4.5 hours? What if a student studies 4 hours and a half? What is he predicted to get in the exam according to this model? Okay, excluding any other independent variables, right? So that would be y is the exam that we are, or the exam score that we're trying to predict, right? Y will be equals to A is 54.65, right? I will just write this here so that we see the formula, but when I do the calculation, actually I will use the real A because it has many decimal points and it will be a little bit more accurate. So that will be equals 54.65 plus the B is 3.78 times 4.5, which is 4 hours and a half, right? I didn't put any parentheses here because we already know the order of operation. The multiplication goes first, then we do the addition. So y in this case, right, will be y equals, then I'm going to have to go here, equal, right, 54.64, which is A, plus B times 4.5, that will be 71.66 points. So a student who studies 4.5 hours for an exam, which is low by the way, okay, you should study more in a week, will be predicted to get 71.66 hours. And if you really are satisfied with 71 points, then you should study only 4.5 hours. I think you should study 8 or more. Okay, so this is how the calculation of the regression formula, the slope, intercept, and the whole regression equation would be done in Excel. Okay, hope you get a really better grade than 71 points. See you next time.